Everyone, welcome back to the channel Knowledge for You. Today I'm going to tell the most important questions from the unit Architecture of 8051. This subject is MPMC, Microprocessor Microcontrollers, common to ECE, EEE and Instrumentation branches. So here I am discussing the most important 1 mark and 3 mark questions from the second unit. The first one is, what are SFRs? Means what are special function registers and their purpose. So in examination you can expect write few SFRs or write few special function registers. Then the answer is, first one is A register, nothing but accumulator. So see here, accumulator means it is a 8-bit register. It is a 8-bit register and it is the default register, and it is the default register to store the result of ALU. To store the result of ALU is nothing but accumulator. The first special function register is accumulator. It is a 8-bit register. It is a default register to store the result of ALU, arithmetic and logic unit. And the next one we have register B. It is used in case of multiplication or division. In case of multiplication, the higher byte of the result, which result? Multiplication result. The higher byte of the multiplication result will be stored in B register, and in case of division, remainder will be stored. In case of division, remainder is going to be stored into the B register, and in case of multiplication, the higher byte of the result is going to be stored in the B register, and register A and B are called as math register or CPU registers. These two are called as math register or CPU register. So next we have PSW, program status word. This is the status flag register. Program status word at the status flag register. It is a 8-bit register, in which the first bit we have the carry bit, carry flag bit, and next there is parity bit. We have parity flag. Next undefined. Next we have overflow flag. Next we have register select 0, RS0, RS1. Next we have user defined F0, and next to auxiliary carry and carry bit. So 1, 2, 3, 4, 5, 6, 7 auxiliary carry. So here we have the parity flag bit, overflow flag bit, register select 0, register select 1. Next user define, that is user define F0 and auxiliary carry flag. So these are the total PSW status registers. And next special function register we have stack pointer. So stack pointer is a special purpose register. Stack pointer is a special purpose register. It is used to point to the top of the stack. So it always points to the top of the stack. So it is a special purpose register. It always points to the top of the stack. Top of the stack. It performs two operations. One is push operation, second is pop operation. Push means inserting the data onto the top of the stack is known as push operation. Pop means deleting the data from the top of the stack. Entering the data onto the top of the stack. Entering data onto the top of the stack, and pop means deleting the data from the top of the stack. Deleting the data from the top of the stack is known as pop operation. So next we have DPTR, data pointer. It is a 16-bit register. Data pointer is a 16-bit register. Data pointer is a 16-bit register. It is a 16-bit register. It is divided into two halves. One is DPL, data pointer low, and DPH, data pointer high. Next timer mode register, T mode register, timer control register, TCON, serial control, SCON, serial buffer, data buffer. Two registers are reserved for interrupter, that is interrupt enable and interrupt priority. IE and IP, these two registers are used to manage the interrupts, to handle the interrupts. And next we have power control, PCON. So this is used to control the power of the microcontroller. And the last, it has 4 ports, P0, P1, P2 and P3. It has 4 ports, P0, P1, P2 and P3. Each port has 4 bits. Each port has 4 bits. So these are the special function registers and their function. So first one we have accumulator register, register B. program status word, which is also known as status flag bits. This parity bit, undefined, overflow flag, register select 0, register select 1, user defined, auxiliary carry and carry bit. Next, DPTR, data pointer. It is a 16-bit register. It is divided into two parts, DPL and DPH. Next, timer mode register, timer control register, serial control register, serial data buffer, and two registers are used to manage the interrupts, interrupt enable and interrupt priority. Next, to control the power, it has power control register, and 4 ports it has P0 to P3. Okay, and next you can also expect the question from ports, that is port 0. Port 0 is used for multiplexed. Multiplexed means combined. Multiplexed address and data, multiplexed lower byte, multiplexed lower byte address and data pins, that is AD0 to AD7. Multiplexed address and data pins, that is AD0 to AD7 lower byte. And P1 is used for IO operations, input output operations. Next, P2 is used for higher byte address bus, higher byte address bus, that is A8 to A15. And P3 is used for dedicated, P3 is used for dedicated input output operations, dedicated input output operations. These are the 4 ports it has, and every port has got 8 pins, total 8 for the 32 pins. And the next one is, these 4 ports operates in how many modes of operation? The next important question is, the port 0, port 1, port 2 and port 3, these 4 ports operates in how many modes? It operates in 4 modes. It operates in 4 modes of operation, that is mode 0. It is known as mode 0. Next we have mode 1, mode 2 and mode 3. So these 4 ports operates in 4 modes. So that is mode 0, mode 1, mode 2 and mode 3. Mode 0 is known as 13-bit timer. Mode 1 is known as 16-bit timer. And mode 2 is nothing but auto reload. Automatically the data will be loaded, auto reload mode. And mode 3 is known as split timer mode. Split timer mode. Okay, so these 4 ports operates in 4 modes, mode 0, mode 1, mode 2, mode 3. Mode 0 is known as 13-bit timer, mode 1 is known as 16-bit timer, mode 2 is known as auto reload, and mode 3 is split timer mode. So this is all about special function registers. And that the most important one is also stack pointer. Stack pointer is a special purpose register. It is used to store the data or address. It always points to the top of the stack. It keeps track of the top of the stack. It performs 2 operations: push the data, pop the data. Push means inserting the data onto the top of the stack is known as push operation. Deleting the data from the top of the stack is known as pop operation. While performing push and pop operation, the SP, stack pointer, will be automatically incremented and decremented based on its direction. Next we have the next important question, organization of program memory and data memory. So program memory refers to ROM. Program memory refers to ROM. Always the program is going to be stored in the ROM, read-only memory, and the data is going to be saved in the RAM. Data is going to be saved in the RAM, random access memory. Then 8051 controller has got, so this is one of the important features. You can write this answer in the feature of 8051 also. That is 8051 has got 4 kilobyte of internal ROM. It has 4 kilobyte of internal ROM. So it can addresses up to the memory address range is 0000 to 0FFH, and it can be expandable up to 64 kilobytes of external memory. So this is nothing but it has 4 kilobytes of ROM. It can address range is 000 to 0FFH and can be expandable up to 64 kilobytes of external memory. So 4 kilobytes means, if I write it as, kilo means 1024 bytes. If I multiply these two, I'll get 4096. The starting address will be always from 0 and then end will be what, 4095. If I divide 4095 with 16, converting the decimal to hexadecimal, you will get this address location 0FFF. So program memory refers to what? ROM, read-only memory. Then 8051 has 4 kilobytes of internal ROM and it can address range is 000 to 0FFH and it can be expanded up to 64 kilobytes of external memory. Next, coming to data memory. So data memory refers to what? RAM. So it has 128 bytes of internal RAM. Then the address of these 128 bytes, the address is ranges from 00 to 7fh. 00 to 7fh. So 128 bytes means always the address start from 0, then the ending byte will be at 127. So if you convert 127 to hexadecimal number system, then we get the answer 7f. So it can address range up to 00 to 7fh. Now, how we are dividing this 128 bytes of RAM? So we are dividing into three parts or three segments. The first one is the first 32 bytes. The first 32 bytes are reserved for register banks. It has 4 register banks. 8051 controller has 4 register banks. The first 32 bytes are reserved for 4 register banks, and whose addresses ranges from 00 to 1fh. And next 16 bytes are known as bit addressable area. So whose addresses ranges from 20h to 2fh. And the remaining 80 bytes also known as scratchpad or general purpose RAM, whose addresses ranges from 30h to 7fh. So this is the 128 bytes of memory, how the 8051 controller is managing. It is divided into 3 segments. The first one is 32 bytes is used for register banks, and next 16 bytes is reserved for bit addressable area, and the next 80 bytes are reserved for general purpose RAM, whose address range is 00 to 1f. It's also easy to remember. 32 means it starts from 0 and ends at 31. Then if you convert this 31 to hexadecimal number system, divide with 16, we get what? 16 minus 16, remainder will be 15, nothing but f. So 1f is the ending location. So 00 to 1f, next 20 to 2fh, and 30 to 7fh. That's how the 128 bytes of RAM is allocated for memory. And next, the most important question for 1 mark. Which pin is used to demultiplex? Address bus from data bus. And the answer is ALE. ALE stands for address latch enable. So address latch enable is used to demultiplex the address bus from data bus in 8051 microcontroller. For this, which port is reserved for multiplexed address and data bus? Means the answer is port 0. So port 0 is used for multiplexed address and data line, that is 80 to 87, where A refers to address and D refers to data lines. So here port 0 is used for multiplex address and data lines. To separate this address line from data lines, or to demultiplex this address lines from data lines, ALE pin is used, ALE signal is used, that is address latch enable is used. Okay, and the higher order address will be stored in ports 2. Port 2 refers to what? Higher byte address lines. Purpose: separate address and data lines for external memory access. Okay, so ALE pin is used to separate or demultiplex the address lines from data lines. This is one of the important 1 mark question. And next, how many timers are available in 8051 controller? The next question is how many timers are there in 8051 controller, and the answer is 2 timers are there, that is timer 0 and timer 1. Timer 0 and timer 1. Each timer is of 16 bits. Next, serial. What are the timer modes? Timer operates in how many modes? Means already we have discussed it. Operates in 4 modes. There is mode 0, mode 1, mode 2, mode 3. Mode 0 is known as 13-bit timer. Mode 1 is known as 16-bit timer. Mode 2 is 8-bit auto reload mode, and mode 3 is split timer mode. So these are the 4 modes of operation of timers. And next, what are the serial port modes of operation? So 8051 controller has got one serial port also, which has 2 pins. One is transmit data pin, second is receive data pin. Okay, so it also operates, the serial port also operates in 4 modes of operation: mode 0, mode 1, mode 2, mode 3. Mode 0 is known as shift register mode. Mode 1 is known as 8-bit UART. Is a variable baud rate. 8-bit UART, variable baud rate. Baud rate means number of bits per second. Baud rate means number of bits transmitted per second. So mode 2 is known as 9-bit UART with fixed baud rate, and mode 3 is known as 9-bit UART with variable baud rate. And the next important question is, what are the interrupt system of 8051? So So 8051 has got total 5 sources of interrupt. The first one is external interrupt 0, that is INT 0. External interrupt 0. Next we have timer 0 overflow, that is TF 0. External interrupt 1, that is INT 1, interrupt 1, and timer 1 overflow means TF 1, and serial communication interrupt. Serial communication interrupt. These are the 5 sources of interrupt of 8051. External interrupt 0, timer 0 overflow, TF 0, external interrupt 1, timer 1 overflow, and the last one is a serial communication. See here which registers are going to manage these interrupt means 8051 has 2 registers to manage this interrupt. One is IE, second is IP. IE means interrupt enable, IP means interrupt priority. Interrupt priority. And the next question is write down the priorities of these interrupt means the first priority goes to interrupt 0, and the next priority goes to timer 0 overflow, next priority goes to interrupt 1, next TF1, and the least priority goes to serial port. The transmit interrupt and receive interrupt. The highest priority will be received for interrupt 0. So see here features, it has 5 interrupts and 2 registers are used to manage this interrupt. One is IE, second is IP. So these are the most important 1 and 3 marks questions. So in the further video I will discuss few more questions. Please like, share and subscribe to my channel. Thank you.